Good morning, students. I hope you're all doing well. Today we're going to be looking at distance time graphs a little bit more. Based on what we did in the last lesson, we need to definitely do some practice on drawing the distance time graph, and also we need some more practice on calculating average speed. So let's move on to the starter and then we'll go into the lesson. Here's the starter problems for you to do. You have 5 questions. Spend no more than 10 minutes completing them. Then resume the video to check your answers. Okay, for our first question, we have 5x minus 3 is equal to 3x minus 7. So we're going to subtract 3x from both sides. 5x minus 3x is 2x, and then minus 3. 3x minus 3x is 0, so we're left with minus 7. Next step is to add 3 on both sides. So minus 3 plus 3 is 0, so we have 2x, and minus 7 plus 3 is minus 4. Our next step is to divide by 2. 2 divided by 2 is 1, so we're left with 1x. Minus 4 divided by 2 is minus 2, so our answer is x equal minus 2. Our next step is to expand and simplify. Our next question, expand and simplify. For the first bracket, we have 2x on top and minus 1, 3 to the left, then we work that out. 3 to 6, so we have 3 times 2x is 6x, and then 3 times minus 1 is minus 3. On the other bracket, we have plus 2 and 2x and minus 3 on top. So 2 times 2x is 4x, and 2 times minus 3 is minus 6. So those are our 4 terms. We got 6x minus 3 and 4x minus 6. Then we'll simplify. 6x plus 4x will give us 10x, and minus 3 minus 6 will give us minus 9. So that's our final answer. Next, we need to work out 45 divided by 18. I'm just going to use a fraction method because 9 can go into both. So I'll divide the numerator and denominator by 9. 45 divided by 9 is 5, and 18 divided by 9 is 2. 5 divided by 2 is 2.5. Our next question is to increase 55 by 10%. So we'll find 10% first. To find 10% of a number, we'll divide by 10. So 55 divided by 10 is 5.5. Okay, and we're increasing 55 pounds by 10%. So we add 55 to 5.5, and that gives us 60.5. And because it's money, we have to write 60 pounds and 50 pence. Our final question is a ratio question. I'm just going to do it over here. We're going to share 540 in the ratio 4 to 5. Right, so what we're going to do is add the ratio. 4 plus 5 is 9. Then we're going to divide the 540 by 9, which gives us 60. Then we're going to multiply each number in the ratio by 60. So 60 times 4 is 240, and 60 by 5 is 300. So the ratio that we're supposed to get is 240 pounds to 300 pounds. So for today's lesson, the first thing we're going to look at is working out average speed. So as a reminder, speed is equal to distance divided by time. And in a distance time graph, notice we have distance on the vertical and time on the horizontal. When we find the gradient of our distance time graph, it is equal to the speed. Because when we find the gradient, we'd find the height of the triangle that we create, the 90-degree triangle that we create, which is distance. And we would have divided it by the base of the right angle triangle we create, which is representing time. in this graph. And so speed is equal to distance divided by time. So when we are going to find speed from a distance time graph, we need to use the gradient of the line to get our speed. So please make a note of that. Pause the video, copy. If you didn't copy it in the last lesson, then resume the video to continue. Now we're going to look at interpreting distance time graphs. So here's our graph that we're focusing on the right. We need to answer the questions that are written on the left. The first one says we should find the length of time spent stationary. We know on our distance time graph, if our line is horizontal, flat, on a distance time graph, then it means that the object has stopped or the object is stationary. Now we need to find on the graph where the line is horizontal. So that's this part of our graph from here to here. So we need to check the time that the object is stationary. So that's going from 2 to 4 hours. So the object is stationary for 2 hours. Then says find the speed for the first moving part of the journey. Now the first moving part of the journey is this slant line here. So we need the whole speed. Notice it's steady speed, constant speed, because the line is straight and sloping. So we need this entire, right angled triangle. Apologies for my line. We need this entire right angled triangle. Its gradient will give us the speed. So the change in distance or the height of that triangle we've drawn is 120, and then the base of the triangle, which is our change in time, is 2 hours. So to find speed, we know is equal to distance divided by time. The distance we got was 120 kilometers on that triangle, and time was 2 hours. So we divide that and we get 60 kilometers per hour. Because we're dividing kilometers by hours, then it gives us kilometers per hour. If it was miles divided by hours, then it would be miles per hour. For part C, it asks us to work out the speed of the second moving part of the journey. That's this slant line here. So again, for that bit of the journey moving part, the second part, we're starting here and we end up over here. So we draw a right angled triangle. Find the height of that triangle. It's 30 kilometers, going from 120 to 150, and then the time for that is 2 hours, as we're going from 4 hours to 6 hours. Okay, so the speed, which is distance divided by time, would be 30 divided by 2, of course, kilometers and hours there in the respective places. 30 divided by 2 is 15, and we'll get the units to be kilometers per hour. Now for part D, it asks us for the total distance traveled. So we started from 0 distance, we went up to 120 kilometers, and then we went up a further 150, we went up another 30 kilometers. So from 0 to 150, or total distance travel would be 150 kilometers. It asks us for the total time. So we've gone from 0 hours to 6 hours for the entire journey. So it would have taken us 6 hours. Now, F asks us for the average speed. Now, average speed is total distance over total time. So for part B, if they've asked you for the average speed of the first moving part of the journey, it would have still been the same thing. It's just where you started to where you stopped that we're looking at. Now, they ask for the whole journey's average speed. So we need a total distance for the journey and the total time for the journey, and that will give us the average speed for the whole journey. So average speed, total distance divided by total time. We worked out those two values in D and E. So we'll have 150 kilometers total distance and total time 6 hours. And then we just need to calculate the value. 150 divided by 6 is 25, so we'll get 25 kilometers per hour. Remember to write this example down, pause the video, copy the example, then resume the video to continue. Let's look at another example. Okay, we need to find the length of time spent stationary. That's here to here. Our time is in hours. So let's work out these intervals. I'm going to do it in terms of minutes to make it simpler. So half an hour is up to this point. Between half an hour we have 3 boxes. So half an hour is 30 minutes. Divide that by 3, get 10 minutes each. So I've written in red in terms of minutes. So the time that is spent stationary is 20 minutes. It says work out the speed for the first moving part. Here's our first moving part. So we need the entire right angle triangle here or to calculate the speed. The height is 15 miles for that right angle triangle, and for the base of the right angle triangle is 10 minutes. However, we need to calculate the speed in terms of hours, miles per hours. So we need to calculate 10 minutes, because that's 10 minutes from this point to this point. 10 minutes in terms of hours, that's just as a fraction 10 out of 60, which is 1/6 of an hour. So we have 1/6 of an hour for the base of our right angle triangle. So all we need to do now is work out the speed. Speed is distance divided by time. So the distance is 15 from the right angle triangle, and it's miles. And the time is 1/6 of an hour. When we divide 15 by 1/6, we get 90 miles per hour. The next question says find the speed for the second part of the journey. So we need the entire right angle triangle for the second moving part of the journey. So the height there is 10 miles and the time in hours is half an hour, right? So we'll do speed is equal to distance divided by time, 10 for the distance and half an hour. So that gives us 20 miles per hour. Then the total distance traveled, we can see we're coming from 25 down to 10 and then from 10 down to 0. So a total of 25 miles. Then the total time for the whole journey is 60 minutes or 1 hour. So we're going to write 1 hour. It now says calculate the average speed for the whole journey. So we need the total distance for the whole journey and the total time. The total distance for the journey we worked out in these 25 miles. The total time for the journey is 1 hour. So we divide that and we get 25 miles per hour. Now for your task, I've given you 5 questions here to do. Pause the video, spend no more than 20 minutes getting them done. Resume the video when you're ready to check your answers. Here are your answers. Pause the video and mark, then resume the video to move on. Now we're going to practice drawing distance time graphs. So here's our first example. James walks to the shop from his home, which is 2 kilometers away. He does this in 15 minutes. He then is in the shop for 5 minutes, then leaves and walks to school, which is 3 kilometers away, and that takes 25 minutes. So we need to draw a distance time graph to show his journey. Let's label the axes. So we have distance here, which is in kilometers, and time, which is in minutes. Now it says James walks to the shop from his home, which is 2 kilometers away, over 15 minutes. So from the 0 mark, go to 15 minutes and then go up to 2 kilometers. And that's where he would end up on his walk to the shop. And we connect those 2 points. It says he then is in the shop for 5 minutes. So another 5 minutes from 15 minutes would take us to 20 minutes. So we draw a horizontal line to show that he has stopped at the shop. And it says he walks to school, which is 3 kilometers away when he leaves that shop, and that's going to take 25 minutes. So here we have covered 20 minutes of the journey. We need another 25 minutes to get to school. So from 20 at 25, we end up with 45 minutes. So we are here, but then from the shop, but then the school is 3 kilometers away from the shop, so that takes us up to 5 kilometers. So we'll connect these 2 points using a ruler. Of course, should be a straight line, and that is how the distance time graph would look for James's journey. Now I'd like you to pause the video and try this question. Spend no more than 6 to 7 minutes getting this done, draw it out properly, then we'll discuss the answer when you resume the video. Okay, so I said Rachel drives from her house to her sister's, which is 100 kilometers away. This takes her 1 hour. All right, for my axis that I have, I'm just gonna label it as distance, and it's in kilometers, and then time is in minutes here, right? So if she travels 100 kilometers away in 1 hour, that's 100 kilometers away in 60 minutes. So I'm going to find the 60-minute mark, then I'll go up to 1 kilometers, and that's how she'll get to her sister's house. So I'm just going to connect that to her starting point. It says she's done with her sister for half an hour, so she spends 30 minutes at her sister's house. Which should take us here. She has stopped at her sister's for 30 minutes. She then leaves and goes to her brother's, which is a further 50 kilometers away from her sister's house. And this takes her 45 minutes to get there. So we're going to check 45 minutes from her sister's house. So far we have 90 minutes. Add 45 minutes, we get 135 minutes. So we'll end up here in terms of time. But then we're going up 50 kilometers further away from her sister's house. So that's where we would end up. And we would connect those 2 points. Right? So use a ruler to draw your line. It says this, yes, so we have the 45 minutes, and then she spends 45 minutes at her brother's house. So she stops for 45 minutes at her brother's house. So we're going to check from there 45 minutes, and that's where we would stop for 45 minutes. The horizontal lines, remember, shows or tells us that there is no movement, that object is stationary. So this is what the distance time graph would look like. Here's another question to try. This time you will have to choose the scale you want to use. However, remember, distance will go on your vertical axis and time will go on your horizontal axis. Pause the video, complete this question within 5 minutes, then resume the video to check your answers. All right, let's look at this. So before we choose a scale, we need to read the question to see how much distance we're covering and how much time we're covering. So Carla walks from her house to her friend's house, which is 2 miles away. That takes her 20 minutes. After she has walked to her friend's house, she has to wait for her friend for 5 minutes whilst her friends get ready. Then they walk to the cinema, which is a further 2 miles from her house. This takes 30 minutes. We need to draw a distance time graph for this journey. Now she walks from her house to Carla's 2 miles away, stops at Carla's, and then walks for another 2 miles further from her house. So that's a total of 4 miles. Okay, so we need to choose a scale that goes from 0, that is useful, that will give us 4 miles. 1, 2, 3. Okay, 2 miles, 4 miles. Okay, equal spacing. Then let's look at the time. It takes her 20 minutes to travel to her friend's house. She waits 5 minutes for her, that's 25 minutes. And then walking to the cinema is going to be 30 more minutes, so a total of 55 minutes. So let's see if our scale, if I can choose an appropriate scale. 10, 20, 30, 40, 50. I need 55 minutes. Okay. So I'm going to choose 10, 20, 30, 40, 50. All right. Okay, I need then 60. Right. So my time is in minutes. So I'm walking, or Carla is walking to her friend's house for 2 miles over 20 minutes. So 20 minutes is there, up to 2 miles. So that's when she gets to her friend's house. She waits for her friend for 5 minutes. Now between 20 and 30 is halfway. So halfway there, that's where she stops at her friend's house to wait. And then she walks another 30 minutes to the cinema with her friend. So we're at 25 minutes and we need 30 more minutes. So that takes us to 55 minutes. And then the cinema is another 2 miles away from our house. Further, so we'll end up at 4 miles altogether for the journey, and we use a ruler to connect to those 2 points, and that would be the distance time graph we need for Carla's journey. So well done on trying that. Here's another example. Erin leaves home at 11 a.m. She cycles at a speed of 16 miles per hour for 90 minutes. She stops for half an hour. Erin then cycles home and travels at and arrives at 3 p.m. We have no scales given, so we need to work that out. We do know that she left home at 11 a.m., so we'll make a note of that, and that is our time. Our distance is going to be in miles, because it says that she traveled at a speed of 16 miles per hour. So we know our distance is in miles. We need to work out how far she got by traveling at 16 miles per hour in 90 minutes. 90 minutes is 1.5 hours. Okay, so we can calculate how far she got. Speed is equal to the distance divided by time. So we know our speed is 16. We need her distance, but we know her time is 1.5 hours. So multiply both sides by 1.5. Okay, so we have 1.5 divided by 1.5, which is 1. That leaves us with 1D. And then 16 times 1.5 gives us 24 miles. So she got as far as 24 miles. So we can mark that there. 6, 12, 18, 24. So that's 24 miles. She does that in 1.5 hours. We need to choose our scale for that to get to 3 p.m. So this is going to be 12 noon. Then here is going to be 1 p.m., 2 p.m., and 3 p.m. So to get to 24 miles in 1.5 hours, that's right here. So we go up to 24 right there. And then you'll use a ruler and connect those two points. Okay, so that should be a straight line. It then says she stops for half an hour, so half an hour more would take us here. So it's a horizontal line to show that she stops. It then says Erin cycles home and arrives at 3 p.m. So we'll just come from it. Didn't say at what speed, but we do know that she's traveling from 24 miles away from home, and she should be arriving home at 3 p.m. So we take a ruler and connect that, and that's where she would end up. So that is the distance time graph that we need to have. Now it says, what is Erin's average speed on the return part of her journey? So we need to work out her speed here on the last part of our journey, right? The height of the right angled triangle is 24, and the time she took to do that was 2 hours, right? That's the base of the triangle. So our average speed, which is speed equal distance over time, 24 miles divided by 2 hours to complete that part of her journey. So she traveled at 12 miles per hour for part B. Here's a question I'd like for you to try. Pause the video, spend no more than 6 to 7 minutes doing the task, then resume the video to check your answers. Alright, so it says Thomas leaves home at 4 p.m. He drives at an average speed of 40 miles per hour for 3.5 hours. So we need to work out how far he gets with that speed over that time. So let's do that. Speed is equal to distance divided by time. We know his speed is 40 miles per hour. We know his time is 3.5 hours, which is 3.5. We need his distance. So we're going to solve this equation by multiplying both sides by 3.5. 3.5 by 40 is 140 miles, and 3.5 divided by 3.5 is 1, so we have 1d. So the distance that he travels at the speed of 40 miles per hour for 3.5 hours is 140 miles. It says he then stops for 30 minutes. Okay, and then he drives home at an average speed of 70 miles per hour. So he got to 140 and stopped. Then he's returning home at a speed of 70 miles per hour. So we need to work out how much time it will take him to get home. So speed equal distance divided by time. His speed to get home is 70. The distance he's traveling is 140, because he would have gotten to 140, then stopped, and from that 140 he's returning home, and the time is what we need to work out. So just need to check, what number do I divide 140 by to get 70? That's 2. So it means that the time he took is 2 hours. So what would that graph look like? Here's our graph. So we're seeing where our axis goes up to 140. He has traveled from 0 distance, ended up at 140 miles over 3.5 hours. We can see that there. So from 2 p.m. to 5:30, that's 3.5 hours to get to 140. Then he stops for 30 minutes according to the question. which is the horizontal line there, and then he's traveling home in 2 hours, we said. So if he's at 5:30, stops for half an hour, that takes us to 6 o'clock, and then we calculated that he took 2 hours to get home. So from 6 o'clock to 8 p.m. would have been 2 hours, so, or a slant line going downwards in the graph. That's what it should look like. So well done on trying that. Here is our final question to attempt. Please pause the video. Spend no more than 6 to 7 minutes completing this question. Once you're through, resume the video to check your answers. Here's the answer. Please mark and make corrections where necessary. Once you're through and you've marked all of your work, send photos of the work through Show My Homework and I will give you feedback. If you have any questions, please send me a message and I will respond to you as quickly as possible. Thank you so much and enjoy the rest of your day.